Hello everyone. Our today's topic of discussion will remain the two-port networks, and this is the part third of this discussion, this chapter. In this part, we will discuss the hybrid parameters, and then after we will solve some examples on hybrid parameters, and after that we will discuss the transmission parameters and we will solve some examples on transmission parameters. So hybrid parameters are basically a bit different than y parameter and z parameter. In y parameters we have some I over some v, and in z parameter we have some v over I. So this can be 1 or 2, and this can be 1 or 2. This can also be 1 or 2, and this can also be 1 or 2. But unlike these two parameters, the hybrid parameters contain either I over v or v over I, or either v over v or I over I. So these things makes these parameters as the transfer admittance or impedance, or rather the gains. So this is the main difference between y parameter and z parameter and hybrid parameter, that y and z parameters both are unique and both are having the properties of some impedance or some admittance. So if we say y parameter, all the four things, all the y11, y12, 21 and 22 would be admittance. We will not talk about impedance in it or gain in it. Similarly, in z parameters we will only talk about admittance. So input admittance, output impedance, reverse transfer and forward transfer impedance. So let's talk about hybrid parameters. Hybrid parameters use the same input and output characteristics, same output sources. Since we are talking about power sources, so power contains I and V. So here we would be having P is equal to I1 V1, and here we will have P is equal to I2 V2. So now we have two different variables that we can vary for this circuit, the I and the V value. So we can vary these variables. Based on these variables, we conclude that this input voltage of this side depends upon the input current and output voltage. So we say that voltage depends upon voltage and current, but self current and opposite voltage. This should be pretty much clearer now. So let's discuss this second equation based on this assumption. The current depends upon the opposite side current and same side voltage. So if we say this is 2, so 1 and 2. Why we are talking about V2? Because here it is I2, so that's why same side current would depend on same side voltage and opposite side current. So these are just the mathematical assumption. There is no such relation of these with a circuit. Why we study these things? We study these things to make the circuit more understandable, to make the circuit more solvable. If we want some problem to solve with this particular circuit, So we can use these parameters and put the values, and we can easily solve this circuit. The same way that we use for the z parameters, that we first calculated the z11, 12, 21 and 22, and after that we added a source and an impedance on the output, and then we solved it very easily. Let me recap that thing. First, we had a circuit like this. So this was our circuit. What we actually did, we calculated Z11, Z12, Z21, Z22 for the equation V1 is equal to Z11 I1 plus Z12 I2, and then V2 is equal to Z21 I1 plus Z22 I2. So we calculated these things first, and then what we did, let me draw it with some other color. We added some source here, and we added some impedance on the output. So that changed these equations, the equation that we wrote. How did they change it? The V1 was replaced with this source, V2 was replaced with this current in this resistance R out multiplied by I2. So that is in the method of solving this circuit so far. But here, let me erase these things because these things are not needed. Here we have another situation. In this situation, we are having the V1 and I2. So that's why it is known as hybrid parameter. First we are calculating V, and then we are calculating I. First we are calculating input, and then we are calculating the output. How these things can be usable? For that, we just recap our amplifier or circuits that involve signals. So what we do, we use some amplifier. We give it some input signal Vi, and then we drive some output, let's say a loudspeaker with it, and this is our output. So this thing needs some power. So amplifier basically amplifies the voltage of the input side and adds up some current from its, let's say, a 12 volt source that is connected to this amplifier. So we are talking about our either amplification factor, the V out by Vn, so V out to Vn, or we talk about some power gain. In that case we talk about the I in this circuit. So I in this circuit can be related to the input voltage, so 1 and 2. So that's why we are saying that this is 1 and this thing is 2. So this is the basic idea of this amplifier circuit. Now let's discuss these two equations, that what are we having in these two equations. So if we check this first equation, in this first equation we are having V1. So V1 is connected to its own current I1, and the opposite side gain V2. So we can say that V1 is connected to its current I1 and the voltage of the opposite side, as we discussed in our previous discussion. So this is 1 and this is 1, so we call this balancing parameter or this relative parameter as H11, plus this is 1 and this is 2, so we call this second parameter as 1, 2. So you have got the idea. Now we are having I2, the current that will be produced on the second side, and we relate it to the current on first side because this thing is current, so we relate it with current. This thing was voltage, so we related it with voltage, plus same side voltage because we are interested in power as well. So here this thing is 2, so we call this 2-1 and we call this thing 2-2. So this is how these two equations have developed. Now we were talking about this first equation, that in first equation we are having these variables which we can eliminate using some short circuiting or open circuiting techniques. So let's apply those techniques. I have already written these things in below slide, in the below of this, in the downside of this specific slide. So here H11 is calculated if we make this side 0. How can we make this thing 0? H12 is the physical parameter values of these resistances and impedances. So we cannot change H12. We cannot say that this thing is 0. If H12 is termed 0, then that would mean that the circuit either does not exist or is a short circuit. So the only option that we have now is this voltage on the second side. So how to make this voltage on the second side 0? Just short circuit this second side and this will make this voltage equal to 0. So we can find H11 by making V2 0. So V1 is equal to H11 and I1. H11 is V1 divided by I1. So this is what we got here by making V2 0. Similar is the case with this H12. For H12 we make I1 equal to 0. How can we make I1 equal to 0? By letting this side open. So first test, we had to close the voltage side, we had to short this voltage side, and for the second parameter we should let this first side open. So this is the method. We can also make the same V2 0 and find H21. So H21 is, that's why written in here. In H21 we are having I2 divided by I1 such that V2 is 0. So similarly, if we make I1 0, that would make V1 divided by I1 and I2 divided by I1, 1 by 1 and 2 by 1. Okay, so this would be the case if we make I1 equal to 0, then we can find these things. So if you make I1 0, we can find these things as well. So now let's discuss this let's discuss the parameters that we got. We have calculated the V1 by I2 or I1. So V by I is R or Z. So that means that these things are impedance, and we call it input impedance because it is on the 1 side. So V1 divided by I1 is H11, which is the input impedance. We cannot call it Z11. Why? Because for Z11 this H21, H12 and H22 must be always be V by I. So this value is termed as the short circuit input impedance because we are having all the values from input and it is V by I, so we call it impedance. If we check this value H21 is actually I2 by I1, so output by input makes it again, and I both are in term of current makes it a current gain, and since it is output by input which makes it forward gain. So this is forward current gain for 2. This 1, 2 is actually 1 by 2 voltage by voltage. So it is a voltage gain, but sorry, we should write it a bit clearer. So this is a voltage gain, but since it is 1 by 2, so we call it reverse voltage gain. Similarly, this is I by V makes it admittance, and 2, 2 makes it output, so this is output admittance parameter. Now coming to this open and short term. Short means that we are using some voltage. So if we check this V20 means that 1, 1 would be a short circuit. Why? Because this side is connected. Okay, these two ports are connected. If we say a thing is open would mean that it is using a current. So H12 is using current, that's why it is termed as open. It is termed as open circuit reverse or forward voltage. It's voltage, so it is reverse voltage gain. So this is the nomenclature of this hybrid parameter, that H11 is 1 by 1, H21 is 2 by 1, H12 is 1 by 2, and H22 is 2 by 2, and the impedance and admittance depends upon the V by I or I by V. So two cases are covered in this, and gain is covered by I by I or V by V. So 2 points are covered by this sentence, and 1 by 2 makes it reverse gain, and 2 by 1 makes it forward gain. So these terms will be used in future. Now going towards the next slide, in which we will discuss the example based on the things that we have learned so far in this hybrid parameters. So here is an example of hybrid parameter. You might might have already recognized that this circuit is a T circuit. T circuits are easily solvable